So what we have learned yesterday is talking about continuous random variable and how to find their expected values, variance, standard deviation, mean, and mode. Okay, those 5 things, how to find those 5 things. And we do one example to show all of that. And we also learn percentiles and quartiles. Okay, percentile is expressed as a percentage, quartile is expressed as decimals. Okay, and it's all referred to the area under the curve to the left of a point. Okay, to the left of a point. Let's have a look at number 6. This is a quite interesting question. So a continuous random variable has this probability density function defined by fx equals to that. Okay, I will define that function first on the calculator. I will wait my calculator. Start and 0 elsewhere. Okay, 0 elsewhere. Let's have a think about the shape of this density function. Okay, let's have a think about the shape of this density function. So we have 4/81 times x times 9 minus x squared. I will store that as a function fx. Okay, I'll start that as function fx. Okay, so let's have a think about this graph. What kind of equation is that? What's the name of this function? A cubic? Okay, if it's a cubic, I can sketch, okay, factorize that as 3 plus x as 3 minus x. So what I will have is a graph. Okay, so I should have a point at 0. Okay, at 0. And I should also have a point at 3. Because you have a 3 as a solution. And you also have negative 3. Okay, you should also have negative 3, but you're not going to have negative values. And this is a negative graph. Okay, this is a negative graph. The full graph should look like, start from the right bottom. I'll go through the first, through the first one, go into the second one, go back to the third one. The full graph should look like that. But we only have domain from 0 to 3. Okay, from 0 to 3. So what we'll have is only this part of the graph. Okay, what we have is only this part of the graph. But be aware that the turning point is not at 1.5. It's not symmetrical. Because this is a cubic graph, the turning point will not exist in the middle of the two x-intercept. So I don't know what is it yet. I will just also we need to sketch 0 here, 0 here. Okay, we have the 0 elsewhere. Okay, we have the 0 elsewhere. Because 0 to 3 is the red one, elsewhere is all zeros. We must sketch for that. We have 0, 0 here, and we have 3, 0 here. Okay, let's first check whether the area under the curve is 1 or not. Open just the calculator, and we have 0 to 3, fx, dx. And that is 1. So this is a probability density function. Everything is above the curve, and the area under the curve is 1. So A is asking us to find the exact value of mean. So find exact value of mean. So Ex equals to, okay, domain is 0 to 3. And I will have the x time with that. Okay, time with that. And x time with fx is how do we find the domain? Well, you should be able to solve this by hand, but because I asked you to do it as homework, so I will just calculate from here to save some time. I'm pretty sure that's just polynomials, you can solve it. So x times fx from 0 to 3. We have 8 over 5. Okay, expect value is 8 over 5. Okay, the important one is the next one. Find the exact value of the mode. How do we find mode? In this question, how do we find mode? The highest point, how do we find turning point? Derivative equals to 0. Okay, so for the fx function, I need to derive the fx function and solve that equals to 0 to find the turning point, x value of the turning point. So what I will have is f dash x equals to 0. Well, I need to really state what is f. Okay, I need to tell you like the steps you may get marked. For example, for this one, you need to state what is f dash x. Because f dash x is not given in the question, that's 1 mark. Okay, and you solve that equals to 0. The value you solve out is another answer mark. Okay, the 2 marks is given by first state the f dash x and second solve for it and give the correct answer value. So, okay, let's say if you just write f dash x equals to 0 and you directly say x equals to blah blah blah, and you can give a wrong answer and that's 0 mark. Okay, you not gain any mark because you are not really sure what is f dash x. So let's find f dash x. Control minus x fx. Well, you should do it by hand. We have that 4 on 9 minus 4 on 27 x squared. And we want f dash x equals to 0. So what we want is 4 on 9 equals to 4 on 27 x squared. So x squared equals to 3. X squared equals to 3. X equals to plus minus root 3. Okay, x equals to plus minus root 3. Because x is only in between 0 to 3, so x equals to root 3. Okay, we need to make a discussion here. Okay, we need to make a discussion here. Why we take the positive? Okay, C is very interesting. C says that without calculation the median, show that it lies between the mean and the mode. Okay, let's label our mode and the mean first on this graph. Okay, our mode is this point here. That is root 3. 8 over 5. Do you think 8 over 5 is on the left or on the right of root 3? 8 over 5 is on the left of root 3 or on the right of root 3? What's 8 over 5? That's 1.6. How about root 3? Approximately 1.73. Okay, 1.732 is root 3. So it's approximately 1.7. The 3 values you need to know is root 2, root 3, and root 5. Like the approximate value for that. Root 2, root 3, and root 5. Okay, root 2 is 1.414, root 3 is 1.732, and root 5 I think is 2.4 or 2.3 something. Okay, just double check with that. Root 5, let's see, root 5. 2.23 something. So root 5 is 2.236. So 2.23. So 3 values. Okay, root 2, root 3, root 5. That's the common numbers we see in the most of the question. So 1.6 is on the left. Okay, we draw 1.6 here. Okay, suppose 1.6 is here. Okay. It says that the median is in the middle of those two numbers, it's somewhere around here, okay, somewhere around here. How you can show that it must exist in the middle? Okay, like this is, I think, a similar VCAR question like that as well in 1 year. It asks you not calculate it, but show that directly from the result you have before. So you have your mean, you have your mode, okay, there's two values. If, okay, let's say if the median is in the middle of that two number, what's the area on the left of the median? What's the area under the curve to the left of the median? 0.5, okay, on the right is 0.5 as well. So if I have a median here, let's make that larger. If I have the median here, okay, to the left of this pink line is 0.5. To the right of this pink line is 0.5. If my median is here, then which means to the left of 1.6 must be less than 0.5. To the right, to the left of root 3 must be greater than 0.5, right? And then in the middle, it will be exactly 0.5. So the left of the blue graph will be less than 0.5. The left to the green graph must be less than, greater than 0.5. Then we can show there must be a number exist in the middle of 1.6 and root 3 that can have the area to the left of that point become 0.5 exactly. Okay, so there must exist a value in between those two to give an exact area of 0.5. So what we need to show now is the area from 0 to 8 over 5 of fx. And the area, that's when probability x less than 8 over 5 and less than root 3. So have 0 to root 3 fx dx. So what we'll have is, let's copy that down. So 0 to 8 over 5. Okay, Control Enter is approximately 0.488, which is less than 0.5. Okay, which is less than 0.5. The area to the left of the blue line is less than 0.5. And then let's change that to root 3. That's 5 on 9. Control Enter. Control Enter. 0.555555. Okay, so it's, that equals to 5 on 9, and it's approximately 0.556, which is greater than 0.5. So the conclusion will be there must be a number m, which m is in between that two values, can give the integral from 0 to m fx dx exactly equals to 0.5. So there must be a number m, which m is in between that, can give that exactly equals to 0.5. Yeah, because here is less than 0.5, and then go 0.1, it will be greater than 0.5. There must be a number in between, just exactly gives you 0.5. So the median is in between 8 over 5 and root 3. Okay, so therefore is in between that. Okay, find the median correct to 4 decimal places. Okay, so it's just 0 to m of fx, and that exactly give us 0.5 dx. Oh, okay. In your stack, okay, a lot of you. What is the easy question? I can't remember the second last page. There's like ask you to set up a differential equation and solve for something. And okay, about like 5 or 6 of you forgot the dx. It's a lot of you, okay? So it's about like 20%, 30% of you forgot the dx at the back. So it's like very easy to miss that, okay? Like when you're very panicky on something and when you're trying to write something really quickly, you will forget the dx. Okay, make sure every time go back to check it. See it as like what I'm doing. I forget it, but I will go back. Okay, I have read the integral. Have I really read the dx? I will go back to check it. So make sure you check it, because if you lose the dx in the end, you will lose 1 mark for the whole paper. Okay, you will lose 1 mark for the whole paper. So any time you forget the dx, you just lose that mark. So you have that function, and we're trying to solve for that. Trying to solve integral 0 to, let's say, a of fx and dx that equals to 0.5 comma x. Oh, sorry, not comma x, comma a. You're solving for a. Okay, so we have 3 values here. Okay, negative 3.9, negative 1.6, and a 4 value actually, 1.6 and 3.9. So I'll only take that one. That one is within the domain. So we have 1.6236. Okay, and that is actually the number in between 1.6 and 1.732. You see that? You must solve a number in between that, otherwise like it's wrong. So we can double check, do we have the correct value? And that's the correct value, is in between those 2 numbers. That's this question here. There's not a lot to talk about in a continuous random variable. Basically, we just keep talking about expect value, variance, standard deviation, mode, mean, and asking in different ways. Okay, it's asking in different ways. And we'll see some application question later as well. They are just like short answer questions, giving really straightforward. There will be some application question at the back. Okay, so let's have a look at the next one. Okay, next one is pretty easy. That's just, no, I don't really need to use cast. Okay, find the exact value of the mode and median for the random variable x with the probability density function that. Okay, with the probability density function that. Just come in. Yes, because I'm in the class. Everyone's in the class. Okay, let's sketch this function first. Okay, let's sketch this function first. Okay, so what do you have? That's truncus function. I can have asymptotes on the x-axis. Can you see the asymptotes? Y equals to 0, and when it is 0, I will have 0, 1. And this graph just looks like that. We have 0, 1 at this point. And we will have 0 anywhere else. It's not like really 0 to a point. It's 0 to infinity. It can take everything under the curve. And then what I will have here is an open circle, okay? The thing I want to mention here is you must have an open circle here. Because 0, 1 is already taking the 0 on the top point. So the bottom one must be an open circle. Okay, the bottom one must be an open circle. So that is 0, 0. And you have 0, 1. That's the shape of the graph. Okay, that's the shape of the graph. So I want to find the mode and median only. Okay, I want to find the mode and median only. So the mode. Okay, what the mode will be? 0. Okay, it's the starting point, which is a 0. And I want to work on median. Okay, work for median. So median is integral 0 to m. 1 over x plus 1 squared dx equals to 0.5 exactly. Okay, let's do this by hand. How do we find the integral for this? What's the integral for this? That's what I want to ask. Okay, like give you a hint, that's x plus 1 to the power of negative 2. What I will have, that's just like gx to the power of n. We'll plus the power by 1, the power become negative 1. We need to divide the power after you add it by 1, and we look at the coefficient for x in the bracket for the linear, which is 1 as well. So that is the integral. 0 to m equals to half. So what I will have is minus 1 on x plus 1. 0 to m, half. Minus 1 over m plus 1 minus 1 over 1 equals to half. I have a plus 1 here. I will have subtract the 1 on that side. You have minus a half. So m plus 1 equals to 2. Then m equals to 1. Then m equals to 1. Okay, this just give you an idea when you're trying to sketch something when the two connect points are not the same point. Normally we have 0 on both ends, and then we have the y equals to 0 after that. But in this case, at 0 there's a point on the top, and you have to start from 0, 0 at the bottom. So one must be open circle, one must be closed circle. And still remember to sketch y equals to 0 for any other points. Okay, and how do we find mode, which is the highest point? Not hard question, just want you to know the shape of the graph. It's quite important to think about the shape of the graph. Alright, then I will show you another question. Okay, show you another one. Okay, this question is very interesting. You can see a lot of exercise on the textbook is about this this function. Okay, so this say the waiting time x hours. Okay, circle that x hours for the next customer to arrive in the shop is known to have a probability density function for that, which a is not given. Okay, a is a constant, which is not given. This is just a density function. So it already says that will become a density function and without giving a, which means doesn't matter what is the a value, you can always have the area under that curve become 1. Okay, so regardless of what a is taking, you always have that as a density function. Okay, so for this function, okay, something just let you know. As discrete probability, okay, discrete probability, we have some really random distribution. When I say x equals to 1, x equals to 3, x equals to 5, and then assign different probability to that, that's a probability mass table as well, but it's not really follow any pattern. But like a binomial distribution, it is a discrete probability. I can still set up the table, but each probability was given by like in some pattern. Okay, so I can use a formula to calculate the numbers, and it's some special discrete probability. So in the continuous one, we have special probability as well. Like what we did before, they're all really random probabilities. Okay, they just for that function, from that domain, it will work. Okay, it will work. So for example, just like this one, for that function, only 0 to 3 can work. If you change any number, this is not going to be a density function. All right, but like what we have here, I can change the a value, and my x can always take from 0 to infinity. Okay, this is a special distribution. But like in high school, we are not really saying, like really telling you this is a special function. But in uni, if you really take probability course, there are a lot of special ones. On your calculator, you can see all of that, like chi-square distribution. This is called a Postum distribution. So you have a special density function. You have special ways to calculate expected value and special ways to calculate the variance and standard deviation, all of that. Just like a binomial distribution. It can use the normal formula to calculate the standard deviation, variance, mean, but it can also have n times p is the mean. Okay, np times 1 minus p is the variance. Can use a shortcut to calculate the thing. So this is a special distribution, because what I'm talking about here is like we have something at the bottom here. Let's start from the beginning. So why this can become a special distribution? Why it is special? First, it's special distribution because I can change the number of a. The a can be anything. It's not really a particular number. I must have that number. Second, I can have my x always become 0 to infinity regardless of what I can take for my a values. Okay, so that's a special one because it always follows some pattern for this, like this function, this type of function. So use calculus to show that fx is probability density function for any value of for a greater than 0. Okay, let's have a think about the shape of this graph first. Okay, let's think about the shape of this graph first. What kind of graph is that? What kind of graph? Exponential. Okay, we have base e. So I should have a graph, increasing graph. But I have negative for the coefficient of x. I will get reflected on the y-axis. So it becomes a decreasing function. Okay, it becomes a decreasing function. So first of all, I want to sketch this function. I need to show that everything is above the fx, at the x-axis. So I will have asymptotes at y equals to 0. I need to sketch asymptotes. And I have a decreasing function. So I will have a function like that. This coordinates will be 0a, because when you substitute 0 into the function, e to the power of 0 is 1, and times a is 0a, and 0 anywhere else. You have open circle here, and you have a line to the left. So that point is 0, 0, but it's an open circle. Okay, it's very interesting here. Same as the previous question. Well, the area under the curve, well, this curve continues forever to your right. You will assume that the area will be greater than 1, but actually not. All the area add up is just exactly 1. Okay, for the infinite area adding together, it's just 1. Okay, why is like that? Let's just have a think about the integral from 0 to infinity of a e negative ax dx. Okay, the integral for that, you need to divide by negative a. So you have negative e negative ax to the power of 0 and infinity. Let's just substitute. Okay, what I substitute is minus e minus a times infinity. Just put the infinity here. Subtract minus e to the power of 0. That is, okay, that's a 1. So it's a plus 1 minus e. Okay, minus a times infinity is still minus infinity. Any number times infinity is just like infinite large number. Okay, so infinite large already times another number is still infinite large. So you have a minus infinity here. Okay, the a doesn't really matter what is the a value. Okay, my question is, what do you think e to the power of minus infinity will be? What number is approaching to? Have a think about the ex graph. 0. Okay, think about exponential graph. That's the exponential graph, right? When x is approaching to negative infinity, the y value is getting closer to 0. So I will treat that as a 0. I will treat that as a 0. So that thing will be treated as a 0. So that area under the curve is just 1. That area under the curve is just 1. Okay, what you need to know here is that is 0. Okay, that is 0. The area under the curve is exactly 1. What else can be 0? What else can be 0? 1 over infinity will be 0 as well. 1 over infinity can be 0 as well. Okay, 1 divided by an infinitely large number, that will be 0. Okay, that will be 0. Okay, so those two things are quite important. When you'll be asked to show something 0 to infinite large, normally it's use those two facts. Okay, normally it's use those two things. So it's approaching to 0 and we treat it as a 0. Okay, now for the next question, given that for this random variable x, expected x equals to 1 on a. Okay, so my expected value is decided by the number of a. Okay, the value of a. And the expected x squared is decided by a as well. It's 1 over a squared. That's why I'm explaining there's a special thing like before, because see that actually having two special formula for this function. I can use the normal way. Okay, how can I say? Make sure you understand that you are not required to remember this formula, and this knowledge is not assumed you will use directly. Only if the question gives you that, the question says that, okay, giving you that, and you can use this fact. Otherwise, even though you know there is a special way of doing it, you can't do this. Well, without giving you this line, you can't find expected value by using 1 over a directly, if that question happens again in another example. Okay, so in other words, if it's not given this line, okay, not giving you this line, you will use the normal way to calculate the mean and standard deviation. What's the normal way of calculating mean and standard deviation? X times fx, 0 to infinity, and so forth. Okay, x squared times fx, so for expected x squared. I can't use that fact. But very lucky we have this fact here in this question because it's given. I can directly use that. So now for part B, we will assume that a equals to 10. So my fx will become 10 times e to the power of negative 10x. The fx become 10 times e to the power of negative 10x. Okay, calculate the probability that the waiting time is longer than 12 minutes. Okay, longer than 12 minutes. Is that correct? Well, I can further write 12 to infinity 10e minus 10x dx. Is that correct? Well, most of the time I ask it's not correct. Where is wrong? Yeah, what's the unit for x? X is in hours. What is given here is only in minutes. Okay, you need to change 12 minutes into 1/5 hour. Okay, 1/5 hour. So I need to change that to 1/5. 1/5. Okay, so what I will have is 0.2 times to infinity. Okay, where's the infinity? It's control and the button of the book. You have the infinity sign here. 0.2 10 times exponential negative 10 times x of the x. That's 0.135335 something. Well, okay, that's not an exact value. How about if I change that? I'll change that to a 1/5. Let's see. You can see we have exact value here. Trying to type answer in the calculator by given fractions, not using decimals. That's what the mode as auto means. Auto means what you give in the question is decimals, I'll give you decimals. You give exact, I'll give you exact. So you can see that's the difference between the two questions. They're exactly the same, but as I express that in the fraction, I will have exact answer here. I will be required for exact answer because in the question, it's nothing indicate that you will round near to how many decimals. So I need to keep my answer as 1/e to the power of 2 or e to the power of negative 2. You need to know how to deal with your calculator. Okay, you need to know how to deal with your calculator. Okay, the average waiting time in minutes. Okay, the average waiting time in minutes. That is expected x. Expected x can be calculated by giving 0 to infinity x times 10e minus 10x dx. Okay, normally I can calculate by this way. But in this question, expected x is given that I can use 1/a to calculate. So a is 10, that's 1/10, but the unit will be hour. The unit will be hour, and that is 6 minutes. And that is 6 minutes. Okay, number 3, asking for standard deviation. We can never calculate standard deviation directly. We always need to calculate the variance of x, which is expected x squared, subtract expected x, and then squared. As given, okay, normally we need to calculate expected x squared by using 0 to infinity x squared times 10e minus 10x dx. I will use that formula to calculate without giving me the fact of expected x squared is 1/a squared. But like this question is given, I can use it, and I will minus 1/10 squared. what is it? 2, sorry, that's 2 on a squared. 2 on a squared. That's 2 over 100 minus 1 over 100. I will have 1 over 100. So as the x equals to square root of 100, that's 1 on 10 hours, that's 6 minutes as well. The standard deviation and variance are the same for this distribution. Okay, variance and standard deviation and the mean are the same for this type of question. Okay, that's a distribution like that. And what you do now and before tomorrow's lesson is finish example 9 and example 10. Example 10 is another question for Postum distribution. It's exactly the same as what we just did. And example 9 is just a normal random distribution, and you can just use the fact of what we have learned so far. Okay, they are not too hard questions. Just do that and we'll compare the answer. And tomorrow, I think we'll just finish this chapter. And next week, we'll start normal.